Hello, this video tutorial is on the Big Ideas Geometry section 2.3 called Postulates and Diagrams. So the two learning objectives are to be able to identify postulates using a diagram and being able to sketch and interpret those diagrams. Okay, so there are a couple different postulates or rules that we're going to be using throughout this section. A lot of these may seem like common sense, but having them actually written out in concrete terms will help you be able to prove if some things are true or if they are not true. So the first postulate is called the two-point postulate. Through any 2 points, there exists exactly one line, and it must be the shortest distance between those in order to be a straight line. Pretty self-explanatory. Then kind of thinking in reverse order, starting with a line. In order to have a line, it must contain at least 2 points. There could be more, but at least 2 points is the bare minimum. Line intersection postulate says that if two lines intersect, then their intersection is exactly 1 point. There's no gray area of how long or how big the overlapping region is. It is exactly 1 point, and in that diagram it's labeled as point C. Then we have a couple more, the three-point postulate. So through any three non-collinear points, there exists exactly one plane. We did kind of talk about planes a little bit in the first chapter. And again, a plane must contain 3 points. So that's what 2.5 plane point postulate is. It's kind of thinking it in reverse order, starting with a plane, how many points does it have? 2.6 plane line postulate. If 2 points lie on a plane, then the line containing them also lies on the plane. So you have a two-dimensional space that is considered a plane, and you have 2 points that are on that plane. That line also lies on the plane. Then plane intersection postulate. If two planes are intersecting, then their intersection is considered a line. So on the previous one, you had a line intersection postulate where two lines intersect to create a point. It's almost like you're going down a level. Same thing with planes for the last one. You're going down a level from a plane to a line. All right, so state the postulate illustrated by the diagram. These are being used with conditional statements, which means they're if-thens. You have a hypothesis and a conclusion. So it looks like you have two lines that are being intersected, and then the second one has a red dot being created in the intersection. So based on that diagram, the postulate would be the line intersection postulate. You have two lines that are being intersected, and there's exactly one red point there. So using that same type of logic to go on to part B, looks like there are two planes that are being intersected, and then the next diagram on the conclusion has a red line between them, so that would be the plane intersection postulate. Two planes intersect, then their intersection is a line. Again, notice that these postulates are also hypothesis and conclusion. You have if, you have then. Okay, using the diagram to write examples of the plane point postulate and the plane line postulate. So in this diagram, we have plane Q being intersected with plane P that creates line M. Then we have line N that is on a plane, and it's being intersected with line M to create the point A. So one way that we could write the examples would be just like that, the plane point postulate, where you have a plane that contains 3 points that are non-collinear. So that plane would be on plane P. There are 3 points on plane P. First one is A, and then B, and then C. So plane P would contain at least 3 non-collinear points. Another example would be the plane line postulate. On the plane, where there are 2 points that lie on the plane, the line containing them also lies on the plane. So this example, on plane P, you have the line AB on that plane, so line AB is on the plane. All right, now sketching our own diagrams, showing that a line is intersecting another line at a specific point. specifically so that those two lines are congruent to each other. So first thing we're going to do is draw line TV and label the points T and V. And that's what you see right here is the line. 2 points starting with T and then going to V. So we're going to draw the point W at the midpoint, and the reason why it's going to be the midpoint is because things are going to be congruent at that intersection. So something's being crossed, and the two segments on the outside of that point are going to be congruent to each other. So it's like almost like it's being bisected as well. So that point W, mark your congruent statements. So this is where you're going to put the dashes through each one. TW is congruent to WV is what that diagram is now saying. Then step 3 would be to draw your intersecting PQ line through that W. It doesn't say anything about the angle at which that the line P needs to be, just that it is intersecting so that you are bisecting the line where TW is congruent to WV. Okay, and then make sure you're labeling your points P and Q. So there are multiple different ways that you can sketch this diagram. The only thing that really matters is that they are labeled correctly so that your P and your Q are on the same line, your T and your V are on the same line. If you're swapping any of those letters, that's not going to be correct. Also, you need to be able to mark them so that you can show TW is congruent to WV. If you're not marking those little tick marks, that does not mean that they're congruent. Okay, which of the following statements cannot be assumed from this diagram? So there's a lot to unpack on this one. The first thing that we should notice is that they are two planes that are being intersected. You have your T vertical plane, and then you have your S horizontal plane. Whenever planes are being intersected, there's going to create a line, and that's what that line BC is. We also notice that there is a right angle here at that line of intersection so that the planes are perpendicular to each other. Okay, so of these 5 statements, which one cannot be assumed? So let's unpack them one at a time. Points A, B, and F are collinear. Remember, collinear means anything that is on the same line. So we're going to first identify where A, B, and F are, and that's where those 3 blue dots are. And it does look like that they are on that same green line. Then we're going to move to the second one. Points E, B, and D are collinear. So we're going to, again, see if E, B, and D are on the same line. Since there is no drawn line that connects them, you cannot assume that they are collinear. They could just barely be off by the smallest of millimeters, and you cannot draw a line that connects all 3. And since it's not on the diagram, unlike the first example, there is actually a line connecting them. Don't assume anything about these diagrams. So now we're going to look at line AB is perpendicular to plane S, and that's what that green line is. Again, I mentioned earlier, you should notice there is a right angle here, and that right angle does mean that it is perpendicular to the other plane. So this is true, and it can be assumed. Then we're looking at line CD being perpendicular to plane T. So this green arrow, the line is highlighted of line CD. And then plane T is what it is intersecting. There is not a marking for this one if it's a right angle. It very well could be, but since it's not marked, we can't assume that. We don't have a protractor. We have no way to measure its slope. So we cannot assume that line CD is perpendicular to plane T. Final one, line AF intersects line BC at point B. So let's highlight line AF, and then let's highlight line BC. It does look like that those 2 lines cross, and they are crossing at the point B, so that can be assumed. So your 2 that cannot be assumed are points E, B, and D are collinear, and line CD is perpendicular to plane T. And that is the end of the video.